Checking the microphone. Let's see. Looks like they're both set up correctly. I want to do a level check. Testing one. Yep. Okay. And I can hear pretty well. So I think we're all good to go. Recording's already started. So let me get into it. Hello, all students. This is like one of the last few videos this week. So all this week I'm pretty much reviewing the previous week, and be going over problems 4, 5, and 6 from the previous problems we demonstrated yesterday. Now, there were a lot of students online, well, 3 or 4, but it was enough to make it engaging and slow everything down. So I didn't finish all 6 problems within the problem set or assessment. So I'm gonna try to finish it now, and we're gonna move on to other topics after this week is over with. Now I'm gonna be going over certain key problems again and again throughout this week, mainly because I have to give you weekly Friday exams. Now, this is just to test and see where you are. It is not to scare you. It is not to harm your grade. I mean, it'll be affected, but there'll be time to, recuperate or recover from whatever grade you get. So let's look at what's going on in ESB. It's these last 3 problems we got to finish. I'm going to share my screen. Waiting for it. There it goes. And it kind of flipped on me because now it's saying this is screen 1. Huh. All right, well, long as it's just on that. Usually screen 2 is me. All right, so anyway, I'm hoping that you can see what I see. So I'm referring to the problem set, which is here. I don't know if I can make that bigger for you. That's a little bit bigger. There we go. So it's to do now basic mathematics and physics. And it goes over a problem where I changed the values, and the values changed, but the problem is not changed from last week. So I'm gonna have you go through. If you need help finding that, we can discuss that later. But what I want to jump into now is problem 4. Now, if I can, I'm gonna try to retrieve the document we used before from yesterday's meeting. So see if it comes up in my recents. Do now, is this it? I think it is the 27th, right? Today's the 28th. So this is, most of the stuff we got through with yesterday. Now we got to move on to, so if we clean this up, this is our question 1. Oh, didn't let me do that. That's fine. Just move around you. We got, this is question 2, right? Lazy fingers just woke up a moment ago. And the last one that we did was question 3. And the solution. The only changes I would make to this, I reviewed the video, and there is a small error. I'm trying to find out where it was. And I'm going to come back to that because I want to check all these calculations. I think one of the steps I multiplied instead of when I should have divided. I don't know if it's this step here or some other step here, but I'll come back to it later. But let's go through question 4, which is, why is it struck through? Let's take that off. Format, there we go, that's where it was. No, there we go. And then I'm gonna go back and grab question 4. And this one is pretty much a volume-based calculation, where in physics you have density, and you can pour water, just to give you a quick explanation, into almost anything, and then it'll form the structure that is in it, that is having to for fill. So with that said, let me take this. I'm gonna go into putting it there, and now we have to go through the calculation. So a warehouse is 1,891 centimeters long, right? And it's 1,712 centimeters wide. 394 centimeters high. What's the volume of this in meters cubed? Now, there's a lot of clues in there. And what we have to begin doing is we started off with the basic math. And now, if you notice, I'm slowly working you into, and Kimion said it yesterday's meeting, I'm working you into the known and unknown values of any problem. So now, this is a physics technique that you use almost all the time. So it behooves you to start picking the problem apart and figuring out what goes in the known values, what goes in the unknown values. How can I use this in any equation that I might know? That's why we set this up. It's kind of like getting your ingredients out of the cupboard and getting ready to cook. So now we're starting to cook with some physics. So known values are what? Values, because I say known and unknowns. I get some students confused, I notice. And then unknown values. So with that said, now we need to look at our problem and see what it gave us and then see what it's asking us. But we kind of already discussed that. If you look at the bottom of the problem, the last sentence, it says here, what is the volume? Well, volume is, we can consider that as a constant or variable as V. So we're going to say V, and jump and turn, but so V is equivalent to some number, put question mark here. Where's my question mark? In meters, and I think it's cube, right? Because it's 3 dimensions. We're going this by this by this, so it's a 3. And where is it at? Hold shift 6 3. So that's for meters cubed. So the arrow upside down, that was another question students ask. What does that mean? I'm sorry, I use a lot of computer science. I used to be an electrical engineer. Well, kind of still are mentally. But honestly, that upside down V means you're raising something to some power. Okay, so let's get back into our known values. What did the problem give us? So if I look here, it says a warehouse is 1,891 centimeters long. It sounds like length, maybe. So let's go through it. Oh, okay, I forgot I edited that with that. So that is L, right? And when you'll start to understand these variables that I'm giving you, like V, L, W, H, goes into equation and I'll pull on the screen for you. But I just want to get you to understand how to start setting it up. And then we're going to discuss how this works in terms of mathematical equations or procedures we use to just make things work. All right. So length is this 1,891, and that's centimeters. So I'm going to put cm. But there's a problem with that, and we're going to discuss in a second. So, because I don't want to get you confused on why is he doing conversions to, why, So I'm just telling you how to pull your information out. So that's what we have here. But bear in mind what I'm getting at, and the problem I'm seeing already is we're in meters cubed, not centimeters cubed. So we have to do a conversion. I know some students gonna be like, this is why I did this recording in advance early this morning. Man, we doing too much, and then this conversation, and we don't get things done. So it's a lot of extraneous convo, and I have to let you know the norms of the Camelot policy we've always had. Non-educational discussion is just, it's not necessary. Focus on the material so you can get out of the class. What else are we given? Wide, we call that W in the equation we're going to discuss, and that's 1712 or 1,712, and that's centimeters. Next, we have what? How high it is, height, and that's going to be about 394 centimeters. Okay, so far so good. All right, now here is what you need to know. We'll come back a sec. I do apologize because I be thinking that we're in a classroom and you can just pull this from your books. So now it's time we get to do some background. Let's pull up what volume, how to calculate what volume is, how to calculate volume. And if we look here, this is probably a good site, but I like the setup. You got width, you got length, and you have height. So all these combined, kind of like the Plantiers, make up volume. They're multiplied together, and that's how you get your meters cubed. So I'm going to copy this here and pasted it right there so you can remember that. And we're going to put that right in the center. So it's at the forefront of our mind, our mind's eye. Now, coming down, we got another issue, and I hope you all understand what this means. These are all measurements in terms of, let me slow down because I've been told I move too fast. So this volume is measured in meters cubed, and it's equivalent to a length, L. I wanted to match the known values I have down there. So you make the connection, okay? So that L is measured in meters, multiplied by our width, W, if you see it down there in the known values. That's why I'm doing it the way I do it, but some people are like, you should have did it this way. No, I got to give you a lot of background before we get into the problem, because I'm going to be expecting you to have what equation you use, your known, unknown values, all the steps to what you calculate. A lot of you guys are just giving me a single answer, which is showing me you probably Googled it and just threw it back at me. That's regurgitation. I'm going to need you to stop being mediocre and actually try to do the math, okay? So let's go through it. The last one is height, right? And if we look at that, that's in meters as well. So when you multiply a measurement by our dimension, we're still talking about dimensional analysis here, meters, length, meters, time, seconds, so on and so forth. Those measurements, or even pounds, how much you weigh, such and such pounds. Those are dimensions. Now, that's meters times meters times meters. If you understand your basic mathematics that you learned in arithmetic in elementary school, that's going to be m to the power of 3, okay? Need help with that? I'll get you worksheets and you can, refresh, put a little oil on the rusted bicycle and get back in motion. Now, let's come all the way down. Our next issue is our length, width, and height are all in centimeters. Please do not take these numbers and just automatically throw them together, all right? When you do that, you end up making life hard for yourself because the material gets harder, and when you cut corners, you pay for it in the end. So let's delve into the centimeters is actually what? We discussed this a while back, and this is yesterday's work. So remember, there's a millimeter, there's a kilo, there's a mega. What is centa? All right. Now, I think previously I gave you guys a link. I'm going to see if I can find it again. I'm going to type centa and see what it says. So you see it's 1/100th. All right. But I want to see if I can find that breakdown that I gave you guys and gals. Yes, I did. I found it. So can you see here that 10 to the negative second power is always going to be centa. So if you see centa, we have to convert it, right? So you're going to be like, oh, we got to put something over 1 and we got to cross things out. Well, we're at a point where I think you get it, but I'm just going to, for the sake of time, go through it without the actual cancellations. So I'm just showing you a quick way in physics to rewrite it, which will show you why I like physics, because it makes math more logical. It has applications. So come down here. And not every problem's the same, guys. So please stop asking. Can I just, and I'm gonna look at you like, can you just get yourself together? So come on, stop trying to cut corners. So length is equivalent to 1,891, and it's a centimeter, remember? So we're gonna say multiply by 10, and put this in parentheses because I want it to be clean. Raised to the power of -2, close parentheses. And this is going to be in meters now. Okay. Guess what I got to do to the other two? I got to convert those. When we put this together, the problem at the very end of it, if you notice, and this is me making you focus on critical thinking, and don't get frustrated at this point because we still got a lot to do. Think about what you're doing. A lot of times We run off of our emotion, we run off of whatever the wind blows, and that's how we don't do well in the battlefield of mathematics. Okay. So next one is this one, with, right? W, and then well, I could have just copied that part, right? I sure could. That a little better because we still got two more problems to do. So that's going to be, again, this factor here of 10 to the negative 2 power, and that's going to convert it to just what we need, our meters, not centimeters. All right, look, one more to go. I remember talking, I'm gonna bring it up again. I remember talking to Mr. Perry, and he was just doing too much. Y'all gotta stop that. Get some discipline. All right, so, and this is I'm gonna bring this down because my values are going off the screen. So let's see if I can do this like this. Okay, good. And now again, I gotta take this part here because all I'm doing is changing each of our centimeters to pure meters, if you notice, and that's how we get our final answer correctly. So height equivalent to 394, and again, put this here. Okay. So is there anything else to do? Yes, we have to put them all together using the equation from earlier. And that equation is volume, which is in meters cubed, is equivalent to length, meters, times width, also in meters, times height, which is also in meters. And when you put that together, we get what? So let's write out our equation. We have here volume is equivalent to our first value here. Take that. And I'm going to put that here. Multiply by, come up here, take this one. And all I'm doing, ladies and gentlemen, is I'm copy and pasting. That's why I like doing steps. So I always go back and pull it from there. It's a nifty trick I learned in engineering school, Illinois Institute of Technology, where you would have series and series of information. And as a computer science person, and engineers had to also be computer scientists. That's how they made the robots move. That's how they made your inverters, your batteries, all sorts of things, your cell phones, things we take for granted. That's why engineers are important. And I'm showing you the engineering iterative design process or thinking process. So now I'm going to plug this one, bracket that. And the last one is our height, right? And I'm going to put that here, bracket this, put that in there. Okay, so now we effectively are close to the finish line with this problem, but we still got two more. So let's hang in there, okay? Volume is going to be equal to, I'm just going to put the numbers, I'm going to take some of these meters and stuff out and leave it with what's actually there when you calculate it. So when you put that in Google, it'll just populate. So I'm going to take this part, this entire part, it's already got the equal sign, and I'm going to plug it here. So I'm going to remove all the meters because I'm going to put 1 meter outside of all of these. I'm going to say that's meters times meters times meters, so that's meters cubed. And these meters, basically consolidation of all the metrics, right? All right, so cool. And now I'm going to say this is going to be all multiplied by a variable, or I'm sorry, a dimension of meters raised to the power of 3. There's our meters cubed. So now all I got to do is take everything inside of these brackets and go to my, as I always tell students, Google is your friend. Go to open a tab. We get that, we got that. Now I'm gonna try to put these links also in the chat so you can see for yourself what they come from. I gotta look into see if I can, not all websites allow you to make them the PDFs and then share it. So that's the issue there. We'll plug this in here. Maybe it needs to bracket, I'm not sure. And what does it give me? Well, I'm looking at its math. And man, you can trust Google for academics. I'm not sure about, you know, if you say, hey, why is I don't know, some celebrity doing something. It doesn't make sense. So it's 1,200. In fact, I can just take this here. Can I? I sure can. Come here. Okay. That's our solution to this problem, right? So I'm gonna come down one and I'm gonna say, hey, my volume is equivalent to this value, and that's gonna be, as we said before, meters. Because I didn't want to write m cubed and m raised to the power of 3 or m that. Some students actually don't know that that means this part here. Okay, so that's meters cubed. Let me clean this up a little bit. Not 1.5. All right, looking better. And that's your final answer for that. Okay. Next, and again, don't just copy and do this. There's a problem last week where we did this. You can go back and just, I'm not going to do it for you because that's not you learning. You go back, use the techniques in this problem set that we did over 1-2 days, I guess, because the first 3 we had to talk and discuss and get used to Zoom. And now I'm going through in advance and creating this video because, to be honest, I got about maybe 45 more minutes or so before I got to do an actual another call where I invite students to come and discuss issues they're having in EDSI and so on and so forth. All right, and that's from all periods. So let's keep it moving. We had problem 4 done. Now it's on problem 5. So let me go back to EDSI real quick. And this one was short and sweet, so not too bad. And this one is not too bad if you understand how to convert your age from years to seconds. So that's where I got to break back out the little division bars and stuff. So yeah, get get your mind ready for it. All right, so this is problem 5. That's supposed to be this, right? Yeah, that's 4. And it says, how many milliliters are in 3.8 liters? And then there's a hint. The hint says, hey, in 1 milliliter, you have, it's about equivalent to 0.00 liters, 0.1 liters. So those are values that you can say known and unknown. But we got to set it up just as if we was doing our age, right? Remember, we was canceling out our years with years and days with days, and we got all the way down to seconds. So let's get to it. So we take our value that we want to convert, and that is, we're going to put it over 1. So that's the first thing you want to do. Let me set you up. And we're going to go here, and that's 3.8 liters is equivalent to, so we'll do that. Well, not equivalent, I'm saying it's going to be divided by just 1. Because that's the first thing you do. You put whatever you're going to convert over 1, turn into a fraction. If, for instance, and this is hard for some students to consume, to conceptualize, if I said the number 88 is the same as saying the number 88 over 1, would you believe me? Well, it is. They just don't tell you that in mathematics. And if you didn't catch it, now you caught it. So you automatically know what numbers. You just turn it into a fraction and begin working on it. So let me come up here. Let me multiply by, and I'm going to use the hint they gave us. Make it real simple. Now I want milliliters, right? And I'm looking at the hint, and it says 1 milliliter is equivalent to 0.001 liters. So we got to start another fraction bar because we're multiplying these 2 fractions together to cross cancel, as Mr. Perry constantly said. You just cross them out, you're knocking them out. Yeah, you're right, but you got to set it up so it does that. So let me make another fraction bar. And actually having fun with these Zoom meetings because I can get a lot of work done and then send it out to you guys. So I want to be left with liters. I'm sorry, milliliters, because that's the problem. Is how many milliliters? So I'm just going to simply put what the equivalent for a milliliter is in the denominator. So that's 0.001 the liter. Okay. Right underneath. And then with this one, it's the same thing, but I mean, that's the same thing as what was in the hint. It's the equivalent thing. So that's 1 spell liter now. I'm like, what? 1 milliliter. Um, Now I can cancel out the liters, right? So I'm gonna do this. Oh, there we go. I'm like, where did it go? Strike out and strike out. And basically, I can take all this jazz, and what's going to happen is it's going to be 3.8 times just the 1 milliliter or one, because the number's gone. And then it's going to be divided by this down here. So what does that look like? Well, let's begin again. That looks like, if I do this, it's going to be what? Our 3.8. Oh, I'm still in strike through. I figured I had that problem yesterday, and now I figured out what was wrong. All right. Moving at light speed here, Tyler. Okay, so liters is going to be multiplied by um, well, it was going to be multiplied by 1, but you can say anything times 1 is going to be itself, and then it's going to divide out by 0.01. And that's going to leave us in the land of milliliters. I'm going to typing it again because I had a hard time typing it a second ago. I'm just going to take that because I know it's correct. Okay. And it might be plural because we multiplied this. There was 1 before and it was singular. So I'm just trying to put it together. So I pop it in Google. You want these things close together. That means divide. Oh, I got to get rid of the liters part. That's gone. There you go. I think I overdid it with this one. There we go. So let's take this. Let's see here. Okay, I was looking for my tab for that. And then this is going to be this, right? So now it's going to be 3,800. So if I come here, I'm going to make another space for it. Try to make this as simple as possible for you guys. And milliliters. To do that, I could just do this. Here are thing of beauty. All right, so that's done with 5. And it took a while because I'm doing it, I'm typing it out for you guys and stuff. If you're doing it by hand, it shouldn't be that bad, okay? So now, last problem, close to the end, the race, number 6. And then I'm gonna post this video real soon. It takes some time because sometimes when I post things in Edsby, the full video format will not load correctly or take even more time. So what I've been doing is I've been proactive and I figured out how to ping it off of YouTube server by converting it to a YouTube file. That has been getting you guys more speed in terms of getting the videos, utilizing them, and even referring to them later, because I've heard some of you guys can't open up some of my video formatted files on cell phones, tablets, or whatever. Doesn't pretty much is not compatible, I should say, with MP4 formats. So let's get problem 6 knocked out. Let's see here. Give me 1 second. Okay, sorry about that. I had a lot of background noise. So last problem, I want you to understand it, okay? Okay, what was I saying? We want to pull it from Ensby, right? Ah, this problem here, the Star of Africa. All right, So I'm gonna plug it there. All right, now this is a doozy because there's some things going on to get it done. But once you got the hang of it, and I'll break it down as slow as I can. All right, so let's go into it. The Star of Africa, a diamond on the royal scepter of the British crown jewels, has a mass of 562.4 carats, where 1 carat is equivalent to 0.20 grams. Given that 1 kilogram has a weight of 2.21 pounds, what is the weight of the Star of Africa in pounds? All right, let's get into it. So let's see here. We got some known values, but like anything else, you just want to start off. And I'm gonna keep it simple with just the fractions and the conversions, okay? But you can do this as a physics problem if you got that advanced. I'll give you extra credit. But at any rate, for the sake of time, and we were on the last problem and there's still stuff to do. First, take the value you're trying to convert and do what with it. If you don't remember earlier in the previous problem, we just simply took that value and put it over 1. That was a whole discussion I was making. So here it is again. Just like your age, you put it over 1 and get to work on how to get it to seconds. Well, we're going to convert this all the way down to pounds, right? That's the question. That's our unknown. What is this in pounds? Okay, so first I'm going to put the number over 560 for this 562.4 carats. And I'm going to put that over 1. Okay. And make a fraction bar. And another fraction bar because I got a feeling it's going to be needed. And again, this goes pretty much 562.4 carats. Just put it over 1. So now we can start a conversion process. All right, so let's look at it. What are we given? Well, they say 1 carat is pretty much equal to 0.20 grams. So again, we got to set it up so we can cancel out carats. So how do we do that? Well, I see carat is in the numerator here. So now I'm about to place its equivalent cross cancellation out in here. Carat. I'll just say carat so it looks the same. You can see how it does. And the carat's like, if you guys want to ever get married and stuff, they say girls like, certain diamonds. This depending on how many carats you spend, she might like you for a certain amount of time or not. That's how the saying goes. At least that's how I was taught by my pops. So moving on, we got its equivalent factor of 0.20 grams. Okay. All right. So it looks like we can cancel out some things here. But let's keep going and then we'll cancel out last. So this is going to be multiplied by, what do we put here? Remember, the goal is to get all the way down in pounds. And there's a clue right here. It says 1 kilogram. Notice it says given. I'll tell you how to do it's very specific too in physics. Given, and then they'll give you all your values, put that in your knowns. And unknown, what is it asking you? So 1 kilogram, this is what I want to highlight, has a weight of 2.21 pounds. So that's another equivalent factor or conversion standard, right? So what do we put here in the top? Our numerator. We want to cancel out grams, right? But I foresee a problem because you can't cancel out grams with a kilogram. You got to say what it is. So what is kilo? What does kilo mean? So, it's wait time. But I was trying to see if there's the screen was going to work. So it's 10 to the third. Again, this link, I'll try to provide it in the chat. Now, when you write it that way, some people get confused. So it's the same as saying 1,000 or a kilo. So that's a gram. Okay. I hope this is clear on what I did. That's 1 kilogram. So I put 1,000 grams. All right. Now I'm not putting it here. I misspoke there. Putting it down here actually. Once you understand that, I should write that out for you. And then what goes here are 2.21 pounds. Oops. Okay. Now I can effectively cancel out things, but before I forget, let me put what it means. All I did was, if you want to see the conversion, I said, hey, now I would behoove you to do this if you get confused. So just like your standard conversion we did earlier, I wanted to get from kilogram to gram. So that's 1 kilogram. Right? Kg is kilogram in case you're not aware. And how many grams are in 1 kilogram? That's the conversion, right? So in 1 kilogram, that's 1,000 grams. Right? Now, how does that convert? Well, you simply will put what you need in the bottom and convert it. Now, ours is you put what you want, right? Now, just showing you the standard conversion, but this is how you get it to convert. Multiply by, then you put that standard conversion. So I want 1 kilogram to cancel out and leave me with grams. The shift button too long. And this is equivalent to, just making sure you're clear, 1,000. So that's how I converted it to get, oh, let's just space that out some more. So that's how I get that. But this is a step you just kind of got to see before you finish the calculation off. Now, we can cancel out things because you can cancel out the kilograms here. I'm going to strike that through. And we can cancel out the kilograms here. And just strike that through. And we got some stuff to strike out here because the problem's final answer has to be in pounds. So we cancel out carat with carat. Because remember, as I said to Perry, Sherrod yesterday, Sherrod divided by Sherrod is what? He was like, Sherrod. I'm like, everybody falls for that one. It's not true. You're one if you divide by yourself. So this is why these are canceling out, because they become one. And anything times itself is itself. One. Gram divided by gram is gone. Strike through and strike out. And then our final answer is just going to be us multiplying and dividing by 1,000. So we're basically through, y'all. I mean, people are wiping their foreheads like, whew, a whole lot of math. No. They say working the brain out is a form of exercise, and if you don't do it, then you lose it. So you're turning the strike off. There we go. Now, you end up with, I'm going to put it in parentheses so Google can, crunch the number and spit it out to you. So carat gone, gram gone. Now you have pounds. So that's 562, right? This number up top by itself, 0.4, multiplied by, or 0.20, multiplied by our 2.21. And that's going to be all divided by 1,000. And let's not forget, since everything is crossed out, well, not everything, all the things that are crossed out are no longer there, but only what's left, which is how we know we did the problem correctly, is pounds. So let's let Google help us out real quick. Take this and copy it. And I'll put this in the trusty Google calculator and Google what you're doing. What do you think about this? And it gives me that. Now, you got to always pay attention to the digits. I don't know if you can see it on the Zoom share screen, but you see how it computer science based calculated this? If you check that, you got it correct. Now I'm going to take this number, and usually in my class, like I say, only give me 2 digits. Do not give me this whole string of numbers. Just give me like 0 point, and if it's a number like 8 or anything higher than 5, you can round it up. So our final answer is actually 0.25. So hold on. So this all equals 0.25. And this is measured in what? Let's not forget, pounds. Okay. putting the equal signs in there so you guys can follow. I think I just murked it up, but I'm not going to touch that. These are all equal is what I'm trying to say. All right, so that's the end of the video. Really, I've put in most of the grades. You guys, if you see a needs improvement, which is a red mark, that means your score is at least below, I want to say, a D. There's 2 periods of classes that are completely not doing their assignments. They need to log in because we're in the last quarter, and I don't want any sad faces when it comes to the end of the quarter. All right, so if you need help, please log in. Please reach out via ESV. I'm gonna post this. I'm post this in a moment, so you guys can go through it, finish all 6 problems, and then submit it. Do not send me 3 and be like, "Oh, well, I thought you knew I was gonna do that later." No, I'm just gonna lock out the assignment and move on to the next concept. Things are not going to get easier; they only get harder, especially if we procrastinate. Okay. So all that said, let me post this video. Log on, log on, log on. I can't keep stressing that. I'll try to reach out to some of your parents and make sure this is clear. Those of you who do not have actual laptops, I do understand paper packets were mailed out. And if you do that work, what can happen is I need to review it so I can adjust your grade. But if you're not doing anything, because mind you, I'm watching everybody, it's gonna show up. All right. So take it easy and stay safe out there. And Zen, of course.